At the end of last year, I was carrying a bunch of boxes down into my basement workshop, and a few weeks ago, I had an AVID CNC fully assembled without a spoil board or work holding system yet, but still capable of doing a test run of something I 3D modeled. This video is about that process. Alright, time to unpack. I didn't have the camera set up for this. I should have. This is the 4 horsepower spindle. And these are the stepper motors to move everything around. So I'm going to get all the boxes unpacked, kind of set them up around the periphery of where the machine will go, while still giving me access to the sub panel that's over on the wall. And I can start putting things together from there. With an undertaking like adding a CNC machine to your shop, there's a whole lot of new stuff to learn, and it can feel a bit daunting. Work holding and all the new software I'd need to learn were looming largest in my mind at this point. But I tried not to stress about that stuff because getting started only involved opening boxes and organizing parts on my shop floor, and that I know how to do. AVID's online instructions are very good, and if you're considering the machine and want to understand the assembly process you'd be in for before you purchase it, taking a look at these would be a good idea. I put a link in the description if you want to take a peek. Quick note, AVID is not paying me for this video, but they did send me the CNC at no cost, which for a channel my size is a pretty sweet deal. That's important for me to disclose to you, even though I can genuinely say that I'm really happy with all aspects of the machine so far. I used videos that AVID has put out at various points in the build also, like this one to step through cable hookup to the electrical enclosures, and this one from Sammy, who works for AVID, stepping through all of the detail for a Fusion 360 design, toolpath generation, and machine startup. That was definitely helpful.
So now that Mach 4 is enabled, my CNC machine is on, it's connected, I can use the arrow keys on my keyboard to drive my machine around.
There we go.
I'll take my touch plate here and I'll use the corner finding edge to place it on the corner of my material. It comes down, it'll touch the brass plate, come up and touch the top edge and then the inside edge here.
Now it knows where the workpiece is. It should know everything that it needs. Listen to Sammy for next steps.
So we can go ahead and now we can load our G code. So I would say test the spindle and then also run the spindle warm-up program. Okay, let's go ahead and run our program.
Alright, so I got the CNC to make something, and that something is a wooden top for the bench dog posts and magnets that I've been selling for about a year. Oh, beauty. Man. The dog post product has done pretty well. People seem to like the bench dog concept that works with a circular hole so it's compatible with hold downs and it has a magnet to hold up the dog when that's needed. But fabricating a dog top and tapping a hole in it to attach it to the post has been a bit of a sticking point for a lot of people. So I thought the addition of the CNC would be a great way to solve that, and I'm tapping the tops of the dogs before I release them with the table saw so that customers don't need to. The extra sleeve around the outside of the top allows the dog to pivot for angled clamping even if it isn't fully clear of the hole. My bench doesn't have this capability, and on some occasions that's been a bit of a frustration, so the extra sleeve seemed justified. It stays in place when the dog is lifted because there's just enough residual magnetic field from the magnet that holds the dog up to hold the washer that I'm gluing into the bottom of the sleeve. There's a pre-sale link in the description for packs of 4 and 24 of these dog tops. They'll work with dog posts that I've sold in the past, so if you bought those and never got around to putting them in your bench and building the tops for them, this is an option for you. I'm producing these entirely myself, but still expect about a month before I ship them. That's a month from February 14th, by the way, if you're watching this in the future. I'm working out the details of an optimized production system, and it's going well, but still going to take me a little while longer. So what you're looking at is what I'm thinking will be my production model CNC setup for these dogs. So I start with a piece of wood that is the maximum height that I can release these on the table saw, just like you saw me do in the kind of concept prototyping video. This is going to be just high enough for my blade. It is fairly efficient with how the parts are nested in here, so that is a reasonable way to be pretty efficient with the wood, and it gets the cost of the wood down per part to a pretty reasonable level that I'm happy with. I am at a bit of a crossroads with software. I don't have a high level of competency in Fusion 360, and that's what this was modeled in. In fact, there's a lot of broken geometry here that I don't think is going to cause me problems, but I'm clumsy with it. I'm learning. I'm also finding that Fusion 360, although it's a very rigorous engineering program, it is not really set up to do wood CNC work. There's no way for me to even tell Fusion 360 that this isn't a block of metal. So what I've had to do when you go over to manufacturing and you make your tool paths, edit, I have had to just manually change a bunch of these settings for what should be appropriate for wood, but even that is imperfect. What you're seeing here is the tool path and this very tight red spiral that I'm zooming in on right here. That is far too small a step down for every one of these rotations for wood. It's kind of wasting a lot of time, and I can't figure out what settings to tell Fusion to not do this. So the wisdom from people I trust is that I should be using VCarve Pro for just about everything. Well, maybe not everything, but in many cases, VCarve Pro has been recommended as much better than Fusion for doing this kind of work. The problem is it doesn't run on a Mac. I don't want to buy a standalone PC. I've never messed around with a Windows virtual environment on a Mac. I'm kind of leaning towards that as the option. I do want to gain competency in Fusion. It's a very robust engineering modeling software. It's a lot better than SketchUp, and I want to get there. So that's what I think I'm going to be doing. For the purposes of this project, it's 25 minutes to do all this machining. That's not too bad. It'll let me get through the production of these dogs. I can optimize it as I go. I can get better with Fusion. Maybe I can figure out some workarounds for it being more designed around machining metal and get better with it. And I can set up a Windows virtual environment to also learn VCarve for times when that's just better. I think especially if you're going to put a big sheet of plywood down and you're going to cut out a bunch of forms, you don't want to be doing that on Fusion. So got a lot of learning to do, but I'm getting close to the point where I can start the production of these dogs. So check those out, and the link's in the description. Thanks for watching. I'll catch you next time.